Okay, let's turn our hands now to fractional indices. Get your calculator out and try these. Get your calculator and type in 49 raised to the power of 1/2, or 64 raised to the power of 1/2, or 125 raised to the power of 1/3. Okay. Pause the video here and see what answer you get to those. And you should have found that they were the answers you were looking for. 49 to the 1/2 is 7, 64 to 1/2 is 8. So it seems like when we're raising something to the power of 1/2, we are taking the square root of that number. 125 to the power of 1/3 is 5, we're taking the third root of that. So what's our rule number 8? It's going to be if I have some particular base raised to 1 over the power of n, you are taking the nth root of that particular value to the power of 1. So when it was 49 to the 1/2, you were taking the second root of 49 to the power of 1. Or here you were, for 64, you were taking the second root of 64 to the power of 1. Or here you were doing 125, you were taking the third root, 125 to the power of 1. Now, you may not have ever seen this one here, the second root. Well, you have, you just never would have seen the 2 written in there, because we're just used to writing it like this. This is one of the situations in maths where there is a number present, but everyone knows it's there, so we leave it out. For example, x means there is one lot of x. Everybody knows it's one lot of x, so we just leave the 1 out. Same thing with the square root. It's the second root. Everybody knows there's a 2 in there, so we just leave it out. Now, the extension of rule 8 looks like this. If you get your calculator out and type 32 to the 2/5 in there, you should get the answer of 4. Pause the video now and see if you get that. Now, the way that works is the same over here. Whatever the number on the bottom was the root you were taking. Whatever the number on the bottom was is the root you were taking. Same thing here. So the number on the bottom is 5. So we're taking the 5th root of 32. Whatever the number on the top was, it stays there under the root symbol. Whatever the number on the top was, stays under the root symbol. Whatever the number on the top was, stays under the root symbol. So you're taking the 5th root of 32 squared. Believe it or not, that's something I'm going to expect you to be able to do in your head without too much difficulty. Can't touch a calculator. It's fairly straightforward. Now, you could, if you wanted to, do 32 squared. I wouldn't suggest that because I don't know what 32 squared is off the top of my head, so I'm not going to expect you to know it. But if you just ignore the 2 for the time being and look at the 5th root of 32, that is something I would expect you to know, the 5th root of 32. If you have a guess, the 5th root of 32, it's going to be nice and easy for you. It's either going to be 2 or 3 or 4, a nice easy number like that. So let's pick a number. Let's try 2. Let's see if 2, when raised to the 5th power, gets 32. So 2 times 2 is 4, times 2 is 8, 16, 32. Hey, yes, the 5th root of 32 is actually 2. I haven't taken care of that power of 2 yet, so I'd still leave it in there. Final answer is 4. So I will expect you to be able to do ones like that without a calculator. So what does rule 9 look like? It's exactly the same as root 8. Instead of raising it to 1 over a number, it's raising it to m over n. So you will be taking the nth root of whatever your number is to the power of m. In a moment, I'll clear the board and put up 4 examples. Now, most of the examples you're going to have to do from the textbook are going to be in this particular style, where you just have to be able to combine fractions. Just add, subtract, multiply, divide fractions quite easily. So here we have 8 to the half times 8 to the quarter. Now we know from index law number 1, if the powers of the same base, you add the indices. So we have to do 1/2 plus 1/4. So 8 to the power of. Now, when adding fractions, you've got to have a common denominator. The good common denominator will be 4. That one's already over 4. So 1/2 as a fraction over 4 will be 2 over 4. Final answer, a to the 3/4. If I asked you to go and write that in surd notation, you would then go and write a, 4 on the bottom, so you'd be taking the 4th root of a to the power of 3. this particular one, number 2. X, the square root of x to the power of 6. So I'm just going to leave the x to the power of 6 there. And I'll take my radical symbol out, my surd symbol out, and put a fractional index in there. What fractional index? Well, square root means I'm taking the second root. Now we know that when you've got a root symbol, the root number that you're taking goes on the bottom of a fraction. So if I'm taking the square root of x to the 6, it means I'm raising it to the power of 1/2. And then, by one of our index laws, I think it's rule number 4, adds a power to a power notation. So x to the 6 raised to the power of 1/2, I times the indices together. 6 times 1/2 is 3. So the square root of x to the 6 is x to the 3. Now, example number 3. Once again, just dealing with adding, subtracting fractions and multiplying fractions. So, first thing I'm going to do is I'm going to tidy this bracket up. I have a power to a power, so therefore I've got to multiply the indices. So I've got 3 multiplied by 1/3, which is 1. So that's m to the power of 1. I don't need the 1 there, but I'm going to write it in just so it's life a little easier to see. Multiplied by m to the negative 1/3 over m to the positive 1/3. From there, it doesn't particularly matter what you do. You could combine the m's on the top line first by adding their indices, or combine the m's on the bottom line by subtracting their indices. I'm going to combine the top line. I'm multiplying powers at the same base, so I add their indices. 1 plus a negative 1/3 is 2/3. And the m to the 1/3 on the bottom hasn't been touched yet. And then from there, I'm dividing powers of the same base, so I subtract their indices. 2/3, take away 1/3 is 1/3. And there's the simplification of this. Now if I wanted to put it into surd notation, then we know a fractional index is the same as using a radical symbol. So it's the 3's on the bottom, so it's the third root of m to the power of 1. Example number 4. 128 raised to the power of 3/7. So let's just put our rule number 9 into its reverse form. So we're going to do this without a calculator, by the way. So 3/7, so 128. 7 on the bottom number is the 7th root that I'm taking to the power of 3. I do expect you to know the 7th root of 128, or at least be able to work it out. So you take a guess. It's likely to be a very easy number like 2 or 3 or 4. So try 2. If I raised 2 to the power of 7, would I get 128? Let's try. Stick up 7 fingers and go 2 times 2 is 4, 8, 16, 32, 64, 128. It does work. So the 7th root of 128 is in fact 2. I haven't taken care of this yet, so I keep writing it down. And of course 2 to the power of 3 is equal to 8. So again, that's the type of problem that I expect you to be able to do without a calculator. You'll have lots of examples of 1, 2 and 3 in the textbook, and I'll give you some in class on number 4. So I'll see you in class and best of luck with them.